Okay, so first of all, we are just trying to like try to take a look on the cosine functions that the question is looking for, because so basically for this part, okay, so we know that first of all the minimum point should be starting from here, point P, okay. So and then it's just like do the revolutions along the wheel until here, so which is the maximum point, right? So the maximum displacement here is 110. So and then we just do the continuous revolutions until it go back to the original position after 20 minutes, right? So and then if it is in a cosine function, that means basically, so we'll first get a cosine function in terms of, I mean, like this one should be 55. So the original position should be 10, right? Which is the minimum point, right? So and then we try to like get a better drawing for this sinusoidal diagram. So and then for this part it will be the minimum point will be 10, and then the maximum point will be 120. All right. So and therefore within this one should be 65. Okay. So and then actually it will just like kind of like the principal axis, and then it will oscillate along this principal axis, right? And this is the maximum point, which is 10 minutes. And it's like this actually, right? So this is 10 minutes. And then we'll go back to here at around 20 minutes, okay? So, and then compare with the original cosine function. So it's like in this form, right? So this is the original cosine function, right? This is 0, and this is like pi over 2. This is pi, 3 pi over 2, and 2 pi, right? So normally, if we are talking about the original cosine function, it will be in this period, right? So, and therefore, first of all, these two graphs are reversed, all right? So, and therefore, A has to be negative value, all right? A has to be negative value. And actually, A should correspond to the amplitude of the transformed function. And then in this case, amplitude should be 55. So, and therefore, A equals to the absolute A, sorry, okay? Should be 55, and therefore A should be negative 55 due to the reversed process, all right? So, and that is the first part, okay? We just try to find, okay, the correlation between the cosine and the final function, all right? And then the second part is, okay, originally the principal axis is on the x-axis, so that means it's like translating upward by 65 units. So, and therefore we get C should be 65. All right. So, and finally, the most difficult part is about the period, all right? Because we know that the original period is 0 to 2 pi, all right? So let's say if we are talking about y equals to cosine x, all right? If y equals to cosine 2x, so actually the period will decrease, right? From 2 pi into pi, because it's like compressed, all right? All right, horizontal strength, okay? So, and therefore, if we want to find the original period, okay, which is originally it's 2 pi, and then we'll want to find the transformed period. So actually we are just like trying to use this value, and then we use 2 pi divided by this value. Okay, 2 pi divided by 2. If this is 3 pi, if this is cosine 3x, it should be 2 pi divided by 3. Okay, 4 pi, it should be 2 pi divided by 4. Okay, b, that means 2 pi divided by b should be the period, right? And right now, the period here is 20, right? Because 10 all the way, 0, all the way back into the original position. 1 complete revolution, that means 1 period. So, and therefore b should be pi over 10. So this is how we deal with these 3 answers, all right?